Hi, Math 2 students. So today we are going to learn about complex numbers. So complex numbers are numbers that involve the imaginary number, which is I. All right. And it is defined as the number whose square is -1. So in other words, we know that I squared equals -1. So if you think about it, right, if we know that if I squared equals -1, well, if we take the square root, we get that I equals root -1. So keep this in mind. Whenever you have root -1, that is what I is. So, imaginary and real numbers together make up the set of complex numbers. A complex number is any number in the form a plus bi, where a and b are real numbers. All right, so if we have a plus bi, we know that the a part is the real and the bi is the imaginary. So I'm sure you're looking at this, you're like, oh God, this is a lot of words. So really right now what I want you to kind of focus on is this idea that the square root of -1 is I, and that you can have complex numbers that are made up of real and imaginary numbers. Okay, so bear with me. It'll make a little more sense as we do some problems, all right? So it says product property of square roots. So this is the idea that you can kind of split apart square roots if they're being multiplied on the inside. So all this means is that we can split up -2 into -1 times 2, right? So we get -1, root -1 times root 2. And we know that root -1 is I, right? So our answer would just be I root 2. So now let's go ahead and try the next one. Again, we're going to try and split up this root -8. So we've got 2 root, and then we're going to split it up into -1 times 8. So we've got 2 root -1 times, and then keep in mind, right, 8 can be broken down into 4 times 2. So we can even break this down further. We get 2 times root -1 times root 4 times 2, root 2, right? Well, root -1 is I. Root 4 is 2. You can't break down root 2. And we got this 2 out in front. So we're going to multiply these 2s. So we get 4I root 2. All right. So this part here with breaking down the 8 should be pretty familiar. That's really just breaking down the radical. Now we're just kind of throwing an I in there. All right. So same thing with this 48. So again, this should look pretty familiar, right? We should know how to break down a root 48. This doesn't even have a negative in there. So let's go ahead. We know that we could, we're going to want to look at our perfect square sheet, figure out what goes into root 48. We're going to want to break that down into 16 and 3. So we've got 2 times root 16 times root 3. Well, root 16 is equal to 4, right? So we've got 2 times 4 times root 3, 8 times root 3. This should look familiar. Now let's try number 4. Again, we're kind of throwing a negative number in there. So let's go ahead. We're going to break 50 apart. Ooh, we need to keep our 4 out in front. So of course we're going to need a -1. And then we're going to want to break the 50 down using our perfect square sheet. So if you look at your perfect square sheet, you'll see that 25 and 2 are going to be useful. So then we've got 4 times root -1 times root 25 times root 2. This root -1 becomes an I, root 25 becomes 5, and root 2 stays there. We're going to multiply, so we end up with 20I root 2. All right. So now, number 5 is important to note. So far, all these ones where we've gotten an I, there's been a negative on the inside. This one has a negative on the outside. So that actually means, since there's no negative on the inside, there isn't going to be an I value. All right, the negative's just going to stay outside in the front. So we got our negative sign outside in front. And of course, we're going to go to our perfect square sheet. And I'm going to want to break down 98 into 49 and 2. So we've got our negative out in front. We've got root 49 times root 2. Well, root 49 is equal to 7. So we get negative times 7 root 2. Our answer is going to be negative 7 root 2. Number 6, again, we have to go ahead and try and break down root 24. So we're, of course, going to want to use our perfect squares. We've got a negative 3 out in front. We can break down 24 into 4 times 6, which gives us negative 3 times root 4 times root 6. Negative 3 times 2 times root 6, which is going to give us a negative 6 root 6. All right. So now let's go ahead and try number 7. So again, we're going to go ahead and break this down. We're going to have negative 1 times 9. We got root negative 1. Ooh, that's a 7. Times root 9. Root negative 1 is equal to I. Root 9 is equal to 3. So your answer here would be 3i. Notice again how in 5 and 6, the negative is on the outside, right? So you just kind of kept the negative there. But for number 7, the negative is on the inside, which means we're going to end up with an I. All right. So now I want you to go ahead and try number 8, right? You're going to want to break down root 32. Of course, you need to use your perfect squares. We're going to do negative 1 times 16 times 2. So we got root negative 1, root 16, root 2. We end up with I times 4 times root 2, which gives us 4i root 2.